Okay, so if you're watching this, it's because you played in the dodgeball game. So it's a really quick lesson. I'm hoping I'll get all of my examples worked, so I'm going to have to talk fast. We're solving log equations. We're going to do two different kinds today. The kind where we have just one log on one side of the equal sign. On the other side of the equal sign, we do not have a log. And there can't be anything on this side of the equal sign, the one with the log, except the log and what we're taking the log of. Now, we're taking the log of all of this, so this one is set up and ready to go. What we're going to do is do the inverse operation. What's the inverse operation of logging something? Raising something to the fourth power. Having an exponent to the base of 4. So because this is a base 4, we're going to write down a base 4, and the exponent on that base is going to be log base 4 of 3x minus 1. And we're going to do the same thing to the other side. Put a base 4. So both of these things right here became the exponent. Okay, that's the inverse operation. So what's going to happen right here? These two things are going to cancel out, leaving you 3x minus 1. We don't have a need for the parentheses anymore, so you can leave it off, is equal to 4 squared. Now, you can multiply 4 times 4. That's going to give you just a simple linear equation now. Add 1 to both sides. 3x equals 17. Divide both sides by 3. And x is equal to 17 over 3. So you want to be sure when you're solving these log problems, because our domain on our log functions, you remember our log functions look like this. The domain was restricted. The domain was only x values that are greater than 0. Because we have that restriction on the domain, we have to check these and make sure that we do not get an extraneous solution. That means a solution that we got algebraically, but it's not going to be in our domain. Now, by the way, this right here is not the domain of this log function. It's just the domain of the basic log function, but I just wanted to remind you that it was a restricted domain. To figure out what the domain is here, you would have to, use your parameter changes. It's just super easy. All you got to do is do log base 4, 3 times 17 over 3 minus 1. Okay. This right here, log base 4, 3 times 17 over 3 is just going to be 17, because those two cancel out. 17 minus 1 is 16. And we all know that 4 raised to the second power is equal to 16. So that checks. Okay, so what do? When we have a log problem, we make each side become the exponent. Cancel those out. And then this thing over here is equal to this side over here. Okay, let's do it again. So what are we going to do? We are going to, this is a base 3, so this becomes 3 raised to the log base 3 of x minus 1 equals 3 to the 5th power. Both of these things right here became the exponent of 3. Okay, what happens right here? Those two things cancel out, leaving you x minus 1. And 3 to the 5th power is, holy smokes, I don't know. 3 to the 5th power is 243. I put those parentheses there, but we don't need them. X equals 244. Plug that in to make sure you don't get an extraneous solution. Log base 3 of 244 minus 1 equals 5. And that's log base 3 of 243 equals that. 3 to the 5th power equals 243, so it checks. Okay. Another one right here, we have one log. Nothing on this side of the problem except the one log. So all we got to do is take the base of the log, make it the base of the exponent, make all of this up here be the exponent, Do the same thing over here. Okay. So what happens? This stuff right here cancels out, leaving you 2x minus 3 equal to 8. Where did the 8 come from? 2 to the third power. Solve for x, add 3 to both sides. 2 to the x equals 11, divide by 2, divide by 2, x equals 11 over 2. Plug it in to make sure it's not an extraneous solution. Log base 2 of 2 times 11 over 2 minus 3 equals 3. Those two things cancel out. 11 minus 3 is 8. Log base 2 of 8 equals 3. Does that check? 2 to the third power equals 8. Okay. What if we have a number in front of the log? It doesn't matter that this is not a log. This is a natural log, so it's still just a log. But this time, the log and what we're taking the log of is not all by itself. This time we have a 4. So what do we have to do? Just simply get rid of the 4 first. Divide by 4, divide by 4. That becomes natural log of 3x equals 8. Okay, we have one log. What we're taking the log of equal to a number over here. So what do? We take the base. What's the base of this? E. It becomes the base, and over here, E becomes the base of that. Okay, those two things cancel out, leaving you 3x equal e to the 8. Divide both sides by 3. X equal whatever e to the 8th power is divided by 3. You'd have to use a calculator and get an approximate value. I'm going to not waste my time to do that because you can type that in the calculator. Okay, so what do you do when there's logs on both sides? Okay, this is even easier. If the logs are on both sides and there's nothing else over here, no number up front or no plus sign on the back or anything like that, then all you simply do is drop the logs and you just solve that equation as if it was just a regular old algebra equation. Subtract x from both sides. X minus 3 equals 4. Add 4 to both sides. X equals, oh, I'm not doing that right. Add 3 to both sides. My bad. Add 3 to both sides. It's because I'm in a hurry. That ends up being 7. Check for extraneous solutions. Log base 3 of 2 times 7 minus 3. Does that equal log base 3 of 7 plus 4? Well, 2 times 7 is 14. 14 minus 3 is 11. And over here, 7 plus 4 is 11. So we got log base 3 of 11 equals log base 3 of 11. So it checked. What do we do here? Log base 5, nothing else. Drop the logs. 7x minus 2 equals 3x plus 6. Solve simple math algebra problem. 4x minus 2 equals 6. Add 2, 4x equals 8. Divide by 4, got x equals 2. Plug it in to check. That gives me log base 5 of 7 times 2 minus 2 should equal log base 5 of 3 times 2 plus 6. 7 minus 2 is 14. 14 minus 2 is 12. So we got log base 5 of 12. Is that equal to log base 5? 3 times 2 is 6. 6 plus 6 is 12. Okay, so I didn't quite finish because I have example C here, and I do want to do that, so you'll have to watch one more video. Sorry.